Alright, so welcome to our mathematics class. We shall be looking at the topic number bases. The idea of number base is to understand the base by which every number is being added or subtracted or multiplied. The number base that we use is base 10. That is the normal base, the normal number base that we use. But there are other bases by which we can carry out our operations, such as base 2, base 4, base 5, and other ones. The computer basically uses the binary number for its operation. We want to look at conversion of one base to the other. So if you have a number in base 10, for instance, if you have 478, this is a number in base 10 because after 8 we have 9, after 9 we have 10. So we can't have a number like 10, over here. We could have 0 to 1. Or if you have a number such as 10101, this is a number in base 2. If you watch these numbers carefully, none of them here that goes beyond 1. It's either 0 or 1. If you have 2 here and we are told this is a binary number, then this is going to be wrong because we have exceeded the base 2. Let's take a look at this example. We have to convert 476 base 8 to base 10. Now to convert to base 10, so from the back we have the 6 here as the first number, which is 0, the second number here, which is 1, and the third number here, which is 2. If you look at the value system, 6 represents units. Here is tens and here is the 100. Alright, so with this, we will now rearrange it and say that 4 multiplied by the base, which is 8, multiplied by this power. So we have ascribed power to each of the numbers, plus 7 multiplied by 8 to the power of 1, plus 6 times 8 to the power of 0. So we shall have 4 times 64 plus 7 times 8 plus 6 times 8 raised to power 0 is 1. So any number to the power of 0 is 1 according to indices. 4 times 64, that gives 256. 7 times 8 gives 56. And here we have 6. So when we add all this together, we have 318 base 10. So we have succeeded in converting 476 base 8 into base 10. We have 318. Let's look at another example. We have 24013 base 5. We want to convert it to base 10. Now to convert this to base 10, we would ascribe it a power. First one being 0, second one is 1, 2, 3, and 4. And so with that, we could say 2 multiplied by 5 times the power, which is 4, plus 4 multiplied by 5 raised to power 3, plus 0 multiplied by 5 to the power 2, plus 1 times 5 to the power of 1, plus 3 times 5 to the power of 0. So we have 2 multiplied by 5 raised to power 4, 625, plus 4 times 5 to the power of 3, that gives 125, plus, now we may not bother writing this because 0 times any number gives us 0. Okay, and so we have this out, then 1 times 5, which is 5, plus 3 times 5 raised to power 0, which is 1. So 3 times 1. So 2 times 625, that's 1250 plus 4 times 125, that gives 505 plus 5 plus 3. When we add it together, we shall get 1763 all in base 10 as our final answer. Number C, we have 110101 base 2. We have to convert to base 10. So to convert this to base 10, just as we've been having it, we shall have 1 times 2. So we have 0, 1, 2, 3, 4, 5. So we shall have 1 times 2 raised to power 5 plus 1 times 2 raised to power 4 plus 0 times 2 raised to power 3. You may not bother writing it since it is 0. It's going to give you 0 at the end of the day. Plus 1 times 2 raised to power 2 plus 0 times 2 raised to power 1 plus 1 times 2 raised to power 0. So 2 raised to power 5, that gives 32. 32 times 1, which is 32. 2 raised to power 4, that gives 16. 16 times 1 is 16. 2 raised to power 3, and then 0 is out. 2 raised to power 2, which is 4. 4 times 1 is 4. And then this also gives 0. 2 raised to power 0 is 1. 1 times 1 is 1. So when we add all this together, we would have 53 base 10 as our final answer. Alright, so we have to convert from base 10 to other bases. We have to convert 124 base 10 to base 3. So we are converting from base 10 now, and this is how it is done. 124 base 10 to base 3. So we'll use 3 as the divisor. 3, just like we are looking for else, the factors of a particular number. 3 into 12, that gives 4. 3 into 4, that gives 1. There's a remainder of 1. We use the same 3 again. 3 into 4, that gives 1, remainder 1. 3 into 11, that's 3, remainder 2. 3 into 13, that gives 4. 3 times 4 is 12, then remainder 1. 3 here, 1, remainder 1, then 3 here, 0, remainder 1. Now to get the numbers, we would have a rule from 1 below here upwards. So we'll take our first number, which is 1, 1, 1, 2, 1, and that is base 3. So we have converted 124 base 10 to base 3. Let's look at another example. If we have 53 base 10 to base 2. Now to change this to base 2, just like we have had here, so we have base 2 divided by 2. 2 into 5, that's 2, remainder 1. 2 here, 6, remainder 1. 2 here, 1, 3, we have 0. Then 2 here, 6, remainder 1. 2 here, 3, remainder 0. 2 here, 1, remainder 1. And 2 here, 0, remainder 1. So we take our numbers from below. So we have 110101 base 2 is our answer. So we converted from 53 base 10 to base 2. Alright, so we could be asked to convert from one base to another base. That is, it could be from base 7 to base 8, base 2 to base 9, except base 10. So to convert to base 10 or from base 10, we will follow the procedure that was treated above. But for instance, let's say we want to convert from 134 base 5 to base 2. Now for us to do this, we can't convert straight away. So what we'll do first is we'll convert from base 5 to base 10. And then from base 10, we'll convert to base 2. So let's go about that. So we have 134 base 5 now. So we shall have 0, 1, 2 as the power there. So we have 1 times 5 raised to power 2 plus 3 times 5 raised to power 1 plus 4 times 5 raised to power 0. So we shall have 1 times, so we shall have 1 times 25, that's 25. Then 5 raised to power 1 is 5. 5 times 3 is 15. and then 5 raised to the power 0 is 1. 4 times 1 is 4. So when we add this together, we'll have it as 44. So this is 44 base 10. Now, we'll now convert it from base 10 to base 2. So 44 base 10 to base 2. We'll have 44 here, and we have 2. 2 here, 22, remainder 0. Because 2 times 22 gives us 44. 44 plus 0 is still 44. Then 2 into 2, 1. 2 into 2 here, 1. Then 0 again. 2 into 22, that's 2 times 5 gives 10. Then remainder of 1. 2 into 5 is 2, remainder 1. 2 into 2 is 1, remainder 0. 2 into 1 is 0, remainder 1. So we take our numbers from down. So we have it as 1, 0, 1, 1, 0, 0, base 2. So we have converted from base 5, that's 134 base 5 to base 2. Alright, so we shall be converting decimals from one base to the other. So first, let's look at converting a decimal number which is in base 2 to base 10. So if we have 101.011 base 2, we want to convert it to base 10. Now, to convert this, we would expand just as we've been expanding when we are converting to base 10. And so we'll have it as, now this is the value, the place value of 1 here is the units. And so we have it as 0, and this is 1, and this is 2. What about the decimal side? Now for decimal side, we'll have it as -1, while 1 is -2, and this other one is -3. We can start from here, and don't forget we are working in base 2, so we shall have 1 times 2 raised to the power 2 plus 0 times 2 to the power of 1 plus 1 times 2 to the power of 0. Then we move on to the decimal side, where we have 0 times 2 raised to the power -1 plus 1 times 2 to the power of -2 plus 1 times 2 to the power of -3. If you would like, just to make it distinct, you could have it in brackets like this. Alright, so we'll simplify this, we'll work this out. 2 raised to the power 2, that's 4, and then 1 times 4 gives 4, and then 0 times all this still gives 0. Then 1 times 2 raised to the power 0, 2 raised to the power 0 is 1, then 1 times 1 is 1. And then we have 0 times this. Now 0 times whatever still gives us 0. Plus 1 times 2 raised to the power -2. Now this is a form of indices. And when we have this means 1 times 2 raised to the power -2, that's 1 over 2 squared. The reason is that the negative power has changed into 1 over, then we have 2 to the power of 2. Same thing goes for this. We'll have it as 1 over 2 raised to the power 3. So don't forget that this 1 multiplies it, and that still gives us the same number. Alright, so we shall have 4 plus 1, that is 5, plus, we will simplify this, 1 over 2 squared is 4, and then 2 raised to the power 3 is 8. We'll find the LCM of this. So let's find the LCM of this first. We'll have it as 8. 4 into 8, that's 2. 2 times 1 is 2, plus 8 into 8, 1. 1 times 1 is 1. And so we'll have 5 plus 3 over 8. And that will give us 5 whole number, 3 over 8. So we could get our answer in decimal. So 3 divided by 8 gives us 0.375. So we shall have it as 5.375 as our final answer. Let's look at another example. If we have 0.124 base 5, we want to convert it to base 10. Alright, so to go about this, our first 0 here still is 0, and then this one that is here is -1, minus 2, and minus 3. So we shall multiply and expand. So we have 0 multiplied by 5 to the power of 0 plus 1 times 5 to the power of minus 1 plus 2 times 5 to the power of minus 2 plus 4 times 5 to the power of minus 3. Now this gives us 0, so we don't need to really bother about this. But this will be 1 over 5, because 5 raised by minus 1 is 1 over 5, plus we have 2 over here. And so 2 over 5 raised by minus 5, that is what? 5 squared. So raised by minus 2 as minus there has brought the 5 squared down. And so we have 4 over 5 raised power 3. We have 1 over 5 plus 2 over 25 plus 4 over 125. We look for the LCM, which is 125. 5 into 125, that gives 25. Then times 1, that's 25. And then 5 into, that's 5, 25 into 125, that gives us 5. 5 times 2 is 10. Plus 125 into 125, that's 1. 1 times 4 is 4. So when we add all this, we shall get 39 over 125. So when we convert this into the decimal using the calculator, we shall have 0.312 to base 10. Likewise, the first one, we have our answer in base 10. Alright, so we want to look at conversion of fraction or decimal numbers in base 10 to base 2. Base 2 basically, as well as converting from other bases to another, which is not base 10. So let's take this first example. If you have 9 whole number 7 over 8 base 10, we want to convert it to base 2. This is interesting, so we need to follow closely. Now when we look at this, we have 9 whole number, which is in base 10. So we separate it as 9 base 10 as well as 7 over 8 base 10. We will convert this 9 base 10 to base 2 first. We have base 2 because we are converting it to base 2. 2 into 9 is 4, remainder 1. 2 into 4 is 2, remainder 0. 2 into 2 is 1, remainder 0. 2 into 1 is 0, remainder 1. And so we'll take it from down. We have 1, 0, 0, 1, base 2. We have succeeded in converting it to base 2. Now we will take this 7 over 8, and this is the one that is very exciting. We have 7 over 8, which is in base 10. Now the idea here is to expand this 7. Look for numbers that are multiples of the base that we are looking for, which is 2. So multiples of 2 that we can have here, that when we add it up together, it gives us 7. So if you say 1 plus 2, 3. 3 plus 4, which gives 7. So these are numbers that when you add it, it will give you 7. And they are more like multiples of 2, except you say 1. When we go further, you find that 1 could be termed as a multiple of 2. Now, if you are going to write this, we shall arrange it from the biggest to the smallest. So 4 over 8 plus 2 over 8 plus 1 over 8. If you look for the LCM of all this, you will get 7 over 8. You can try it out. Now, take this to the lowest form. So we will have 1 over 2 plus 1 over 4 plus 1 over 8. Now this is the same thing as saying 1 over 2 raised power 1, 1 over 2 raised power 2, 1 over 2 raised power 3. This is this, and this is this. And we could also say that this is 2 raised power minus 1 plus 2 raised power minus 2 plus 2 raised power what? Minus 3. Now these are corresponding to each other. So we'll have this as 1 times 2 raised power minus 1 plus 1 times 2 raised power minus 2 plus 1 times 2 raised power minus 3. Now these are the numbers that we are going to use. So we'll use 1, 1, 1 because they are the numbers that we use to multiply this 2 raised power, we use this 1 to multiply 2 raised power 1 minus 1 to get this, and then respectively. Likewise, we use 1 to multiply this. That's 1 to multiply 2 raised power minus 2 to get this. And so we have the decimal aspect to be 1, 1, 1. Now we'll combine the 9 of the base 10, which was converted to base 2. We'll combine it with 7 over 8 of the base 10, which was converted to base 2. So we'll have it as 1001.111 base 2. This is our final answer. Alright, so we want to convert 59 over 64 all in base 10 to base 2. Alright, so for us to do this, you see this 59 here. We'll look for numbers that will add up to 59, and they are in base 2, and they are multiples of this base of 2. So let's take 59. We can have 1 plus 2, that's 3. 3 plus 4, that's 7. 7 plus 8, that gives 15. Then we have 15 plus 16, that gives 31. Then 16 plus 32, so we can have 32 here, that's 363. Now if you look at this, it's more like the 63 is already more than 59. So what can we do? What we can do is to look for a number here that when we remove it from this 63 to give us 59. And so this is how we get this particular number that we are looking for, or the numbers that will add up to 59. So if we take away 4, that would give us 59. And so we can remove 4 from here. When we remove 4, it will give us 59. So now we'll rearrange it. 59 over 64 is equal to, we arrange it in descending order. So 32 over 64 plus 16 over 64 plus 8 over 64 plus 2 over 64 plus 1 over 64. Please take note that the 4 that we remove from here will be replaced in one way or the other as we proceed. We'll break this to the simplest term. This gives us 1 over 2. This gives us 1 over 4. This gives us 1 over 8. This gives us 1 over 32. And we have this. So 1 over 2 plus 1 over 4 plus 1 over 8 plus 1 over 32 plus 1 over 64. This means 1 over 2 raised power 1 plus 1 over 2 raised power 2 plus 1 over 2 raised power 3 plus 1 over 2 raised power 5 plus 1 over 2 raised power 6. Alright, so we'll get this in, we'll apply the law of indices here. We shall have 2 raised power minus 1 plus 2 raised power minus 2 plus 2 raised power minus 3 plus 2 raised power minus 5 plus 2 raised power minus 6. Now when we have this, so we'll multiply it with 1. 1 times 2 raised power minus 1 plus 1 times 2 raised power minus 2 plus 1 times 2 raised power minus 3. Now we have noticed that minus 4 is missing here. And that means it must have been multiplied with a 0. Because if you multiply that number with a 0, you are going to have nothing. And so we will have it as 0 times 2 raised power minus 4. It is more or less, it is like it is not there. Then plus 1 times 2 raised power minus 5 plus 1 times 2 raised power minus 6. Alright, so we would write the numbers that are here because we are working in base 2. And you know that when you are working in base 2, your numbers must not exceed 1. The possible numbers that you can have there will be 0 and 1. If you are working in base 3, the possible numbers you would have is be 0, 1, and 2. It won't exceed 2, and the rest. So you bring out the numbers here. That's 1, 1, 1, 0, 1, 1. And this is in base 2. So we have our 0 points because we are dealing with a fraction. So because we are dealing with a fraction, that's 59 over 64 base 10, is been converted to base 2, which gives us 0.111011. Alright, let's take a look at this example again. We want to convert 0.5625 base 10 to base 2. How do we go about this? First, let's convert it into fraction by moving the decimal to the front of the 5 which is here. And so we have 5625 over 10,000 because we moved it 4 times. So 1, 2, 3, 4. We will break it down to the lowest term. We have 9 over 16. So we'll take 9 over 16, and just as we've done, we'll look for numbers that when we add it up, it will give us this 9. So we could have 1 plus 2. This is 3. 1 plus 2, which is 3. 3 plus 4, which is 7. 7 plus 8, that gives us 15. So now it is already more than 9. So look for numbers that when we deduct it from here, from 15, we'll get it. So if we remove 4, we'll be left with what? 11. And then if we remove 2, we'll be left with 9. So we'll take off 2 and we'll take off 4. So we'll have it as 8 over 16 plus 1 over 16. Don't forget that we are arranging it from the highest number to the lowest. So we'll have to the lowest term 1 over 2. So we have 1 over 2 plus 1 over 16. And that means 1 over 2 raised power 1 plus 1 over 2 raised power 4. So we have 2 raised power minus 1 plus 2 raised power minus 4. So we have 1 times 2 raised power minus 1. So we have minus 1, but we don't have minus 2 and minus 3. So those two are missing. And that means that it must have been 0 multiplied by the missing powers. Then plus 0 times 2 raised power minus 3. Then plus 1 times 2 raised power minus 4. So the number in base 2 will be 1, 0, 0, and 1 in base 2. That is the answer. Alright, so we want to convert 0.123 base 4 to base 2. Now, we can't convert straight to base 2, but we have to first convert it to base 10. We'll convert base 4 to base 10, then from base 10 to base 2. So let's get that done. So we have our powers as minus 1, minus 2, and minus 3. So we'll have 0 times 4 raised power 1 plus 1 times 4 raised power minus 1 plus 2 times 4 raised power minus 2 plus 3 times 4 raised power minus 3. And so we'll have, this is 0, then we'll have this as 1 over 4 plus 2 over 4 squared plus 3 over 4 raised power 3. So this gives us 1 over 4 plus 2 over 4 times 4 gives 16 plus 3 over 4 raised power 3. That is 64. We have this in its lowest term. This gives 8. So we look for the LCM of all this. The LCM is 64. Alright, so we have it as 2 over 16. And so we'll look for the LCM. So 4 into 64, that gives us 16. Times 1, 16. 16 into 64, that's 4. 4 times 2 is 8. 64 into 64, 1 times 3 is 3. So when we add it, we shall have 27 over 64. So we have succeeded in converting it to a number in base 10. Now we will now convert it from the number in base 10 to base 2. So to go about that, we'll look for numbers that we'll add. We have 27 over 64. The numbers that will join here are 16 over 64 plus 8 over 64 plus 2 over 64 plus 1 over 64. If we add this, we have 16 plus 8, that gives us 24, plus 2, 26, plus 1, 27. So we reduce it to the lowest term. This is 4. this is 8, this is 32. Okay, so we have 1 over 4 means 2 raised power 2 plus 1 over 2 raised power 3 plus 1 over 2 raised power 5 plus 1 over 2 raised power 6. So if you look at it closely, raised power 1 is missing, raised power 4 is also missing. So how do we get that done? So we have it as, so we can have it as 0 times 2 raised power minus 1. We just added that. Then 1 times 2 raised power minus 2 plus 1 times 2 raised power minus 3. Then 4 is missing, so we have it as 0 times 2 raised power minus 4 plus 1 times 2 raised power minus 5 plus 1 times 2 raised power minus 6. So our answer will be 0, 1, 1, 0, 1, 1. Then don't forget that it's in base 2, and also we are dealing with a decimal originally and then fraction, so we have it as 0.011011. So if you want to still understand this better, you can go over the video. Alright, so now we want to look at addition and subtraction of numbers in several bases. We all know that 1 plus 1 gives us 2, and that 2 is gotten in base 10. But what if we are adding in other bases? For instance, if we have this as base 2 and base 2, and we are to add 1 plus 1, it surely will not give us 2, because just as we said, in base 2 the highest number will be 1. So if you have 1 plus 1, yes, let's have it as 2 in base 10. Then this 2 will be converted into a number in base 2, and that will be 2 into 2 gives 1, remaining nothing. Then 2 again into 1, that's 0, remainder 1. So we have 1 and 0 base 2. So we could say that 1 plus 1 is equal to 10 in base 2. Let's try other bases. Let's take 7 base 8 plus 6 base 8. If you have 7 base 8 plus 6 base 8, now adding it in base 10, 7 plus 6, that gives 13, and that 13 is to base 10. Now the base 10 will now be converted into base 8, such as 13, 8 into 13, that gives 1, remainder 5, and then 8 into 1 is 0, remainder 1, and so we have 15 base 8. So 7 base 8 plus 6 base 8 is equal to 15 base 8. Alright, so let's take other larger numbers. Let's say we have 101 plus 111 plus 110. We want to add this, and you can guess that this is in base 2. So to add this, 1 plus 1, that gives 2 in base 10. But we won't write the 2. We'll have it as 2 over 2. 2 into 2 gives 1, remainder 0. So we'll take the remainder here and bring this one over to this place. Then 1 plus 0 is 1, plus another 1, that's 2, plus another 1, that is what? That is 3. So we'll write the 3, rather we'll have 3 over 2. 2 into 3 is 1, remainder 1. So we'll take this remainder, we'll bring it here, and this one we'll have it here. So we have 1 plus 1, 2, 2 plus 1, 3, plus another 1, that's 4. Now we can't write the 4 because we are working in base 2, so we have the 4, then 2. 2 into 4 is 2, remainder 0. 2 into 1 is 1, remainder 0. And 2 into 1 is 0, remainder 1. And so we'll take it just from down. We have 1, 0, 0, 1. So we have it as 1, 0, 0, 1, 0, 0, 1, 0, 0 as the answer. So we've added this. That gives us 1, 0, 0, 1, 0, base 2. Let's take it a bit higher. If you have 264 plus 86 plus 475, we want to add all this in, they're all in base 9. So we want to get our answer in base 9. So let's go on. 4 plus 6, that gives 10. 10 plus 5 is 15. So we have 15 over 9. 9 into 15, that gives 1, remainder 6. So we'll take the remainder down. I'll have our 1 here. 1 plus 6 gives 7. 7 plus 8 gives 15. 15 plus 7 gives 22. So we have our 22 over 9. 9 into 22 gives 2. Remainder 4. Because 2 times 9 is 18. 18 plus 4 gives 22. And so we'll take this 4, we'll put the 4 here, and we'll carry this 2 to this place. 2 plus 2, that gives 4. 4 plus 4, that gives 8. So this is what we'll get in base 9. Okay, so let's take some subtraction. If you have 101 minus 11, this is in base 2. So we could easily have it as 1 minus 1. That gives 0. 0 minus 1. That is impossible. And so we'll come over here to borrow 1. Now when the 1 comes over to where 0 is, it becomes 2. Because, this is more like units, tens, and 100. So when the 100 comes here, the 1 here becomes 2. So we have 2 minus 1. That gives 1. So this is the answer in base 2. Another example. If we have 475 minus 86, we have to subtract this in base 9. So we'll have 5 minus 6, which is impossible. So what we'll do is we'll come here and borrow 1. Now when we bring the 1 here, it becomes 9. So this one is now 6. So we have 9 plus 5. 9 plus 5 gives us 14. 9 plus 5, which we borrowed from here, that's 9, because we are working in base 9. So 9 plus 5 gives 14. Then that 14 minus 6, which gives 8. So we have our 8 in this place. This does not exceed 9. So that's why we write it there. Then we have 6 here. 6 minus 8 is impossible. So what would happen is that we would come over here, we'll borrow 1. And that one that we borrow from here, this one would be 3. When we borrow the 1 from it, becomes 9. 9. Then 9 plus 6, that gives us 15. So we'll say 15 minus 8, that gives us 7. And then we have 3 in this place. Okay, so we want to look at this next question. Find the missing figure if the addition below is in base 4. So if we add all this, that's 2 plus 3, and this gives this. Now when we add all this, it gives us this. So what are we going to do to get this xxx? Which is simple. It's just like you have 2 plus 3 plus x equal to 8. To get your x, now let's say we are working in base 10 here. 2 plus 3 is 5. 5 plus what will give you 8? That would be 3. How do you get that? 2 plus 3, that's 5. Then you say 8 minus 5, that gives you 3. So that's how you get your x. So that is similar to what you are going to do here. So let's have it as 1302 plus 123. When you add this, 3 plus 2, that gives 5. And don't forget that we are working in base 4. So we'll write the 5 down. Rather, we'll convert it to base 4. So we have 1, remainder 1. Because 4 times 1 is 4 plus 1, 5. So we have the remainder first, then put the 1 here. 2 plus 1, that is 3. So we have the 3 here. 3 plus 1, that is 4. But we won't write the 4 because base 4 must not exceed 3. So we have 4 over 4. 4 into 4 is 1, remainder 0. So write the remainder as 0 and bring this one over here. 1 plus 1, that is 2. So we have 2, 0, 3, 1. Now we'll subtract this from 10122. So we have 10122 minus 1302. 2 minus 1, that gives us 1. 2 minus 3 is impossible, so we'll borrow 1 from here, and that one becomes 4. 4 plus 2, that gives us 6. Then 6 minus 3, that gives us 3. Here we have 0 because we've borrowed the 1 from here, so 0 minus 0 gives 0. 0 minus 2 is impossible, so we'll come here and borrow 1. The 1 becomes 4. So 4 minus 2 gives us 2. Base 4. So this is our answer. Alright, so we want to look at multiplication and division in different number bases. So let's take this example. 321 multiplied by 25. We are working in base 6. Alright, so we have 5 times 1, that gives 5. 5 times 2, that gives 10. But we'll not write the 10, because 5 times 2, yes, is 10. So we'll convert it to a number in base 6. So 10 divided by 6, that's 1 remainder 4. So we'll have the 4, and then we'll bring the 1 over here. 5 times 3, that gives 15. 15 plus 1 is 16. We won't write the 16 because it is more than base 6. So we have 16 to base 6. So 6 into 16, that's 2 remainder. So 6 times 2 is 12. 16 minus 12, that's 4. So we'll have the 4 here and we'll put 2 here. Then 2 times 1, that's 2. 2 times 2 is 4. 2 times 3 is 6. So we'll write the 6 because it's a number in base 6. So we have 6 over 6. So that's 1 remainder 0. So we have a 0 first, then 1 next. We add it together. 4 plus 2 is 6. But we'll write the 6 because it's a number in base 6. So that will be 0, bring 1. 4 plus 1 is 5. 5 plus 4 is 9. So we'll write the 9. We'll have it as 1 remainder 3. So we have our remainder first. 3, 1. 2 plus 1 is 3. Then we have 1. So this is the multiplication of this number to base 6. Alright, so we want to look at division of a number base. So we have 2115 base 7 divided by 12 base 7. We want to divide this. Now, there are two methods of getting this done. Because it may be confusing dividing it straight away, it may be safer to first convert 2115 base 7 to base 10, and then convert 12 base 7 to base 10, divide it in base 10. So when you have gotten your answer in base 10, the normal division, then you convert your answer back to base 7. But there is a method too, which is converting it directly, and so I would like us to explore that now. So if you have 2115 base 7 divided by 12, alright, so we'll take it like 12 into 21, that gives 1. And don't forget that we are working in base 7. Alright, then 1 times 12, we have our 12 over here. 1 minus 2, that's impossible. So we'll come over here and borrow 1. Now, when we bring the 1 from here, it becomes 7. So it will no longer be 1 that we borrow, it will be 7. So 7 plus 1, that gives 8. 8 minus 2, that gives us 6. Here we have 1 here, so 1 minus 1, that's 0. So we bring down this 1. Then we have 12 into 61. Now 12 into 61, we are not going to multiply just as we have it in the multiplication table, because in the multiplication table, those multiplications are done in base 10. So we have to multiply it by 12 times what will give us a number that is close to 61. So if we say 12 times 4, 4 times 2, that gives us 8. But we'll not write the 8. We'll convert it to base 7. So 8 over 7, that's 1 remainder 1. So we have the remainder 1 and bring 1 here. Then 4 times 1, that's 4. 4 plus 1, that is 5. So we have 51. 51 is lesser than 61. What if we try 5? If we say 5 times 2, that gives 10. Then 10 divided by 7, because we want to have it in base 7. So 7 divided by 10, that is 1, remainder 3. So we have our 3 here and bring 1 here. 5 times 1 is 5. 5 plus 1 is 6. So we have 6. Now if you look at 63, is higher than 61. So we can't take 5. We'll take 4. So 12 into 61 is 4. 4 times 12 is 51. Do not forget that we are not working in base 10 because 12 times 4 in base 10 gives us 48. Alright, so we subtract. 1 minus 1, that's 0. 6 minus 5, that is 1. And then we have 5 here. Then 12 times what will give us something close to 105. And so let's try. So we know what 12 times 4 is. We know 12 times 5. Let's try 12 times 6. 6 times 2, that's 12. We can write the 12, so we'll have it to base 7. That's 1 remainder 5. So we have our 5 here and bring 1 here. Then 6 times 1 is 6. 6 plus 1, that is 7. We can write 7 because we are working in base 7. So 7 into 7 has 1 remainder 0. So we have our 0 and then 1. So that is 12 times 6. So we have 6 here. So 6 times 12, that is 105. So we subtract it and that's what we get. So 2115 base 7 divided by 12 base 7, and that gives us 146 base 7 as the final answer. Alright, I want to solve this next question, which says the sum of 4 numbers is 1214 base 5. What is the average expressed in base 5? This is more like an average. Now if you add 4 numbers, it gives you 1214 in base 5. So what we will do first is to convert it to a number in base 10. Then we'll look for the average. So let's go ahead. We have 0, 1, 2, 3. So we have 1 times 5 raised to power 3 plus 2 times 5 raised to power 2 plus 1 times 5 raised to power 1 plus 4 times 5 raised to power 0. So we will have 1 times 125 plus 2 times 25 plus 1 times 5 raised to power 1, that's 5, plus 5 raised to power 0, which is 1. So that's 125 plus 25 times 2 is 50 plus 5 plus 4. So when we add all this, we shall get 184. Now this 184 is in base 10. So look for the average. Average is to divide by the particular number of items, which is, in this case, we have 4. So 184 divided by 4, that gives, so 46, still in base 10. So we'll convert this into base 5 because we are expected to get our answer in base 5. So we have 46, then we have 5 here. 5 here 9, remainder 1. 5 here 1, remainder 4. 5 here 0, remainder 1. So our answer is 141 base 5. Alright, so this next question says, if K2 all in brackets then base 6 multiplied by 3 base 6 equals to 3 base 5 multiplied by, now into brackets, K4, everything in bracket, then you have 5. Let me take the question again. If K2 all in brackets, then base 6 multiplied by 3 base 6 equals to 3 base 5, and then times K4 all in brackets base 5. We are expected to find the value of K. Now to solve this question, we would convert everything into base 10 and we will easily get the answer. And so we'll go ahead. So this is taken as a number, that's K2. So we have 0 and 1 here. So we have K times 6 raised to power 1 plus 2 times 6 raised to power 0 multiplied by, this is 3 times 6 raised to power 0 because this one is just a number which is 0, equal to, this is also a number which is 0 as a power. So that's 3 times 5 raised to power 0, then multiplied by, we have 0 and we have 1 here. So K times 5 raised to power 1 plus 4 times 5 raised power 0. And so we shall have 6 times k, that's 6k plus 2 times 6 knots. 6 raised power 0 is 1, 2 times 1 is 2, all into brackets. 6 raised power 0 is 1, 3 times 1 is 3, equal to 5 raised power 0 is 1, 3 times 1 is 3, then 5 raised power 1 is 5, times k, that's 5k. 5 raised power 0 is 1, 4 times 1 is 4. So we'll multiply what's outside with what is inside. 3 times 6 is 18k, plus 3 times 2 is 6, equal to 15k. 3 times 4 is 12. We collect like terms, so we shall have 18k minus 15k equal to 12 minus 6. And we are left with 3k equal to 12 minus 6. That gives 6. We divide both sides by 3. And so we shall have k to be equal to 2. So we look at this next question. It says, find the value of m if 13 base m plus 24 base m equals to 41 base m. Okay, so we have it as this. Whenever you have something like this, to make it easier, convert everything into base 10, because this m may not be base 10. So we go thus. We have 0, 1, 0, 1, 0, 1. So we have 1 times m raised power 1 plus 3 times m raised power 0 plus 2 times m raised power 1 plus 4 times m raised power 0 equal to 4 times m raised power 1 plus 1 times m raised power 0. So m raised power 1 is m, so 1 times m is m. Then 3 times m raised power 0. M raised power 0 is 1, so 3 times 1 is 3, plus m raised power 1 is m, so 2 times m is 2m, plus m raised power 0 is 1, 4 times 1 is 4, equal to m raised power 1 is m, 4 times m is 4m, then m raised power 0 is 1, 1 times 1 is 1. So we collect like terms. We have m plus 2m minus 4m equal to 1 minus 4 minus 3. This is 3m. 3m minus 4m, that is minus m. Then 1 minus 4, that's minus 3. Minus 3 minus 3, that's minus 6. So we are left with m equal to 6. Alright, so looking at this question, we have 4243 minus 13x4 to give us y344. Find x and y respectively in the subtraction above carried out in base 5. So we are working in base 5. Now for this, when we look at it closely, it means 3, the first one is 3 minus 4. And we are working in base 5. So 3 minus 4 will not be possible. So we come over here and we borrow 1. Now the 1 becomes what? 5. So 5 plus 3, that is what? 8. So 8 minus 4, that's 4. We are left with 3 here. 3 minus x, we are saying it's 4. But if you look at this closely, something must have happened before we would have 4 here. Most likely, something has been borrowed. So if 1 was borrowed to come here, that 1 will become 5. So 5 plus 3, that is 8. Now, if you have, for instance, 8 minus x equal to 4, how do you get your x? You get your x by saying x equal to 8 minus 4. And that is exactly what we are going to apply here. So we shall say that 8, which is this, minus x equal to 4. So to get our x, we say x equals to 8 minus 4. Hence, we've gotten the value of x to be 4. And then to get the value for y, if you look at this, when we borrowed 1 from here, we have 1 left. So we have 1 minus 3, which is impossible. And so most likely 1 must have been borrowed from here to come to this place. So we have 3 left here. So 3 minus 1 will give us 2. So 3 minus 1 will give us 2. So y equal to 2. Alright, so let's look at this next question where we have P344 base 6 minus 23P2 base 6 to give us 2PP2 base 6. Now looking at this, we have to find the value of P. Now, what you could do is to convert all this into base 10 first, then you subtract in base 10, and then you will get your answer P. That is a sure way. But at the same time, if you look at the work closely, P is a common value. That is, whatever P is here is the same thing with this and this. Now, you may not be able to get a very good, guess perhaps with this. But if you look at this particular P minus 2, which gives 2, what exactly must have been here to have 2 in this place? We are working in base 6, hence our numbers will be 5, 4, 3, 2, 1. So the numbers that could be here could be 4 or 5, since 4 minus 2 can give 2. Then 5 minus 2 can give, that will be 3. So looking at it closely, we are saying the range is in between 4 and 5. But looking at this as well, we have 3 minus 3. 3 minus 3 giving us P. And we are saying that the answers will be a common number. Now, this particular one here would not be 0 because 3 minus 3 will be 0. So the answer here will fall within the range of 4 and 5 as well. So what number must have been here? 3. That means there will be a number that is perhaps like 2 minus 3 to give us 5. To give us 5 or 4. So we are saying, what I'm saying now in essence is that you could take a very wild guess and then you check to be sure if you are right. So I'm thinking that the best answer that would have been here would have been 5, because if we borrowed 1 from here and we bring it here, we'll be left with 4. So 4 minus 2 will give us 2. So I'm suggesting our answer to be 4. But if we are not going to take it in form of suggestion and we need to work it out, here is what we shall do. So we'll convert everything to base 10. So we start with this. So we have 0, 0, 1, 2, and 3. 0, 1, 2, and 3. So we go thus. We have P times 6 raised power 3 plus 3 times 6 raised power 2 plus 4 times 6 raised power 1 plus 4 times 6 raised power 0 minus 2 times 6 raised power 3 plus 3 times 6 raised power 2 plus P times 6 raised power 1 plus 2 times 6 raised power 0, all equal to 2 times 6 raised power 3 plus P times 6 raised power 2 plus P times 6 raised power 1 plus 2 times 6 raised power 0. So if we solve everything over here, we would have 216P plus 108 plus 24 plus 4 minus into brackets 432 plus 108 plus 6P plus 2, all equal to 432 plus 42P plus 2. So when we simplify and we work this out further, we have 216P plus 136 minus 542 plus 6P, all equal to 434 plus 42P. So when we collect our like terms, okay, we'll have 216P plus 136 minus 542 minus 6P equal to 434 plus 42P. So collect like terms, that is, bring this here and bring this over to that side. So when we do that, we'll have 168P equal to 840. So P equal to 840 divided by 168, and that would leave us with 5. So just as we've said, the best answer is 5. So 5 is the value of P. So looking at this, we have to multiply 231 base 4 by 10101 base 2 to give us m base 6. So the question is to find the value of m. So when we look at this question, what we can do first is to convert all the bases to base 10. And so we'll go about it right about now. So we have 231, that's 0, 1, 2. So that's 2 times 4 raised by 2 plus 3 times 4 raised by 1 plus 1 times 4 raised by 0. So that's 2 times 16 plus 3 times 4 plus 1. And that is 16, that's 32 plus 12 plus 1. That is 45 base 10. And then we have 10101 base 2. That would be 1 times 2, so 0, 1, 2, 3, 4 raised by 4 plus 0. Okay, we leave out the zeros. Then 1 times 2 raised by 2 plus 1 times 2 raised by 0. So we'll be left with 1 times 2 raised by 4, which is 16, plus 1 times 4 plus 2 raised by 0 is 1, so 1 times 1 is 1. So we are left with 16 plus 4 plus 1, and that is 21. So we'll have this in base 10. So we'll say 45 base 10 times 21 base 10. So when we multiply this, it gives 945 base 10. Now that's the answer in base 10. So we'll convert it to base 6. We'll have 945, 6 here, 1, remainder 3, 6 into 34, 5, remainder 4, 6 into 45, that's 7, remainder 3, then 6 into 15, 2, remainder 3, 6 into 35, 6, remainder 1, 6 into 26, that's 4, remainder 2, 6 into 4, 0, remainder 4. So the value of m will be 4213 base 6.